I'll do a little review just to remind you what we were doing. Remember 6.4 and 6.6 were about graphing? Graphing sine and cosine. So quickly, if I tell you just to graph y equals sine x, what do you think? What do you do? How's this work? Yeah, so in general, we started talking about later in the section, we started talking about graphing a sine bx minus c, right? We started talking about adding all these extra numbers in there. But if I just give you y equals sine x with a 1 in front and a 1 in front of the x, how does the graph of this look?
Starts at 0.
Right. So sine, what's the period of sine? How far does it go before it repeats?
2 pi.
2 pi. So the period of regular old sine is 2 pi. And the way our trig functions work is they have something happening every quarter period, something important happening. So you take 2 pi and you break it into quarters. So half and then half again, which will give you pi, pi over 2, 3 pi over 2. Then the pattern for the sine function is that sine starts at a 0, then goes up to a max, down to a 0, down to a min, back up to a 0. And what y value does it reach up here? How high does it get?
1.
1, right? It bounces between 1 and negative 1. So these are kind of the important points on your sine function, and then you connect those like this.
No. Yes.
No! No, it's so ugly. It hurts my eyes. No, it doesn't look cool.
It's Harry Potter's scar.
Harry Potter always
That's risky to say that in math class.
He did it.
So this is sine. Right? Remember, it goes on. I'm drawing these dots just to indicate to you that it keeps going on forever, even though I only graphed a single period. You don't have to do that, but do realize it keeps going on forever. By the way, what would the domain and range be if I asked? Domain of this graph, range of this graph.
Range is 1 to negative 1.
Domain's all real numbers. Why?
Because it keeps going.
It goes on forever in both directions. Right? So as far as your x values go, you go between negative infinity and infinity. And then range?
Negative 1 to 1.
Now, brackets or parentheses? Do I include those? Brackets, because I actually do reach 1 and I do reach negative 1. So what changes if I just have you graph y equals cos x? So cosine instead of sine. Cosine starts from a maximum. That's like the main difference. Right? So you're still going to go out to 2 pi to get one full period. You're still going to break that into quarters. So pi over 2, pi, 3 pi over 2. But the way cosine works is it bounces between negative 1 and 1 starting from a max. So you'll go max, 0, min, 0, max. Something like this is your cosine curve. These guys are up at 1. Down. Domain and range for cosine? It's the same. Both are the same, right? Because it goes on forever in both directions, left and right. That means the domain's negative infinity to infinity, or all real numbers. And the range is you bounce between the same y values, negative 1 and 1. Okay, so that's what we started with last time. And then we did an example where we made it a little more complicated by adding extra numbers in front. Let me do one more review example. Let's graph on the y equals 2 sine of 1/4 x.
So these are just transformations.
Right, these are essentially transformations. There's a little bit different terminology we use with trig functions, but yes, they are just transformations. So kind of the standard way, or at least the way we're going to do it in this class, to graph this is to figure out first what your amplitude, period, and phase shift are. Okay? Those come from these A, B, and C numbers. A in this case is equal to 2. B is equal to 1/4. And what's C? 0, because I'm not adding anything or subtracting anything from the x. And there's nothing being added or subtracted, so C is 0. So then what's my amplitude and what's my period? Amplitude's 2, right? Amplitude is the absolute value of this guy. And what's the amplitude tell you about the graph? The max and min, how far it goes up and down from the x-axis. So that's my amplitude. What's my period? The formula is 2 pi over b. In this case, b is 1/4, so I'm going to have to calculate 2 pi over 1/4. The 1/4 flips up. 2 pi times 4 over 1, or 8 pi. So this 1/4 multiplication out front here actually expanded our period from 2 pi to 8 pi. But I don't really want the period as much as I want the quarter periods, because the quarter periods tell me where everything happens. So I'm going to do another quick calculation and find the quarter period. Where does that come from? Exactly what it says. Cut it in quarters. 8 pi over 4. So all my important points on this sine function are going to happen at intervals of 2 pi. And then the last thing I need is the phase shift, but in this case, it's 0 since C is 0. The general formula is C over B, but that would be 0 over 1/4. Now we can do a decent graph of this guy. So, because we're starting from 0, this tells you where to start. Okay, this tells you where to start graphing your function. I'm going to start graphing my function at 0, and I'm going to end 8 pi later. Okay? And I'm going to have an important point every 2 pi. So what's going to happen is you're going to start from 0, and then every 2 pi you're going to have an important point. And keep going until you get one full period. So that's the first thing I would do, label my important x values. Then, because my amplitude is 2, I'll label my important y values. 2, negative 2. Now all I really need to do is understand how to graph sine. So it comes down to, do I start from a 0, a min, or a max? Sine starts from a 0. It goes 0, max, 0, min. So there's your function. That was the recap of what we did last time. What do you think? Bueno or no bueno? What happens if I put a negative in front of this? It still starts at 0, actually. That doesn't change anything. But what does it do? It reflects it. If you have a negative out in front of your function, it's going to reflect it vertically. Okay. So it's not actually, the amplitude is still 2, because the amplitude is always the absolute value. All right? But and the period doesn't change, and nothing changes except the shape of the graph is going to be reflected. So yeah, instead of going 0 max, 0 min, 0, if you have a negative in front, you're going to go 0 min, 0 max, 0. So this green graph would be y equals negative 2 sine 1/4. You gotta watch out for those negatives in front, because that's going to change your starting direction, right? It reflects it. So, okay, questions? I'm ready to do some phase shifts. Woo, phase shifts. Super excited about phase shifts, Charles. This is my normal talking.
You start at -2.
Yeah, if this were -2 cos 1/4 x, you would start down at a minimum instead of a max. And go to a 0, then max. Alright, so let's do some phase shift. Except that the 2's kind of cut off there. Hold on. So we'll graph the function y equals 3/2 sine of pi x minus pi over 2. This is the example we left off on. We didn't quite get to this one. We have sine of pi x minus pi over 2. Now, when you're labeling A, B, and C, you want to refer to the generic format of y equals A sine bx minus C. Right? In this generic format, when I defined everything, I had a minus inside. It's not going to trick you up if you're paying attention, but if you're not paying attention, that might mess you up. What that means, what that does, is when I label A, that's fine. It's 3/2. When I label B, that's fine. That's the number in front of X. Top. That's B. But C, you want to discount this sign. Don't even worry about this sign. C is just positive pi over 2. And there's kind of two ways of remembering or thinking about this. One way is that there's a minus in the formula here. So the minus you see right here is already taken care of by the formula, which means C has to be positive. That doesn't mean much because we're in the formula, right? So another way I encourage you to think about this is that C sort of keeps track of a horizontal shift. And if you remember the way horizontal shifts work from 126, it's always the opposite of the sign that you see. Right? If you see a minus sign inside of a function, you shift to the positive direction. So if you have a minus sign in front here, your C value is going to be positive. If you had a plus here, your C value would be negative. But at the end of the day, you always want to start graphing in the opposite direction of this sign. If you see a minus, you start graphing on the positive side of the x-axis. If you see a plus here, you start graphing on the negative side of the x-axis. Let's calculate all our values. Amplitude, 3/2. Right, we're going to go 3/2 above and below the x-axis. Period, what's the period here?
2 pi.
You do 2 pi over b in general, which will be 2 pi over pi. After cancellation, that's just 2. That's nice. Quarter period, might as well calculate that. On at it. Quarter period is the period over 4, so I'll do 2 divided by 4. 1/2. Last but not least, my phase shift. What's the formula for phase shift, remember? C over B. So you take this pi over 2 and divide it by pi. C is pi over 2, B is pi. How does it simplify? 1 over pi, you're going to have to flip this pi up. Pi over 2 times 1 over pi. Pi's cancel again because one's on top and one's on bottom. So you're just left with a phase shift of 1/2. happen to be equal, they will not always be equal. This and this tell you something different. The 1/2 for the phase shift tells you that's where you want to start graphing. The 1/2 on the quarter period tells you that's how far you go to get all your important x values. So this is like the length between important x values. And then this guy is your y value. Tells you your max and min y value. Okay. So, I gotta graph this now. Now, the period is 2, all right, but my graph is not going to end at 2. Okay, so I wouldn't start labeling my x-axis like this, because I don't. My first period doesn't end at 2. Why doesn't my first period end at 2? Because it's got a phase shift. It starts off at 1/2. Right, so you're going to end 2 away from 1/2. So be careful. In fact, I would kind of ignore that for now and just start with the phase shift. Here's 1/2. And then according to my quarter period, I can figure out how far I have to go to get my next important x value. I just take 1/2 and I add 1/2. What's 1/2 plus 1/2? 1. And then I add 1/2 again. And then I add 1/2 again. Am I done? How do you know when you're done? When you've gone 2 from the phase shift or when you've gone 4 quarter periods. Right now I've gone 1, 2, 3 quarter periods. So I got to go 1 more, right? 4 quarters and $1 right here. 4 quarter periods. So in between each one of these is my quarter period of 1/2. That's where I'm getting these from.
So you don't start doing the quarter periods until after.
Until you've gone out this phase shift here. This 1/2 is where you start counting everything from.
Oh.
So then I got to do my y values. My important y values are up 3/2, down 3/2. So here's 1, 2, 3/2. -1, -2, -3/2. And then since I'm graphing positive sine, where am I going to start? On the y. What y value do I start at? 0. So right here, right, from 1/2 on the x-axis and 0 on the y-axis, because sine always starts at a 0. You put a point here, then you go up to a max after 1 quarter period. 1 quarter period up to a max. The next quarter period down to a 0. Next quarter period down to a min. Next quarter period up to a 0. It goes on forever. Green graph is the graph of this function. What would be the domain range? What's domain? Negative infinity to infinity, because even though I didn't draw it because I'm lazy, these do go on forever. So the domain for any sine or cosine graph is going to be negative infinity. All right, what about range? Right, you kind of try to fit this guy in a box. The highest y value here is 3/2, and the lowest y value here is negative 3/2. So that's your range, lowest to highest y value. Yes, no, maybe so? Okay, okay. Let's do another one. Because this is so fun and exciting. I can tell you guys are just on the edge of your seats. Please do another one, Josh. Okay, class. Okay, calm down. Let's graph y equals negative 2 cos. Ooh, 3x plus pi over 4.
So that means the pi over 4 will be negative, but you'll have to go the other direction?
Correct. When you start graphing this guy, because there's a plus sign here, you're going to start graphing on the negative side of the x-axis. Let's go through it step by step. We have an a equal to negative 2. Right, we have a b equal to 3. And we have a c equal to technically negative pi over 4. For c, you always change this. And then when we calculate our amplitude, period, and phase shift, technically speaking, although I don't know if I'll ever call you on this, technically speaking, the amplitude is the absolute value of a. So it's 2. What's the negative tell you? You start at a min instead of a max, you reflect. Right? So the negative tells you to reflect, which is important. Technically, the amplitude is always the absolute value. Period. How do you calculate period? 2 pi over b. In this case, b is 3. So our period is 2 pi over 3. Yes? Have an answer?
On an exam or on a quiz, is it okay if we put the absolute value in bars and then for the amplitude and then the negative 2 inside? Would you still count that as blank, right? Yeah.
What's that equal to?
2. But just so that we can remember.
No, you can put this, but then I want to see this.
Oh, okay.
Of all the things that I'm going to catch you on in this class and mark you off for, it's not going to be whether you put a negative amplitude or not. Yeah. It's technically positive, but I don't care that much. What I'm really looking for at the end of the day when I'm grading these is this graph. And if this graph is right, then you're good. And if you happen to have a negative sign out here, I don't care. You got to get this graph. All right, quarter periods. So you got to take your period and divide it by 4. So that's always going to amount to flipping and multiplying by 1/4. And I would definitely simplify 2 pi over 3 times 1/4. Yeah, you get a 2 left on the bottom when you reduce there, so you'll get pi over 6 altogether. Last, but definitely not least, phase shift. So how do we calculate our phase shift? What's the formula?
C over B.
C over B. C in this case is negative, so we get negative 1/4. Right? C over B is equal to negative negative pi over 4. Not 1/4, negative pi over 4 divided by B. Flip and multiply. This is 3 over 1. This becomes negative pi over 4 times 1 over 3. Negative pi over 4. So you see, these are not equal this time. There's no reason that the phase shift in the quarter period has to be. It actually makes your life a little bit more difficult than not. We got to glue this all together onto a passable graph. So when I start marking off my tick marks on the x-axis, I'm going to start from negative pi over 12. So let me just pick where I think negative pi over 12 should be here. And this is the opposite of the sign that you see here, which was plus. Right, so you know you're starting on the negative side. That looks good. Here's the trick, though. You have to now calculate what pi over 6 to the right of that is, and what pi over 6 to the right of that is, and what pi over 6 to the right of that is. So what I would suggest doing is rewriting your quarter period so that it has the same denominator as your phase shift. Save you a little bit of time. Right, so get a common denominator here. How do you write pi over 6 with a 12 denominator? Multiply top and bottom by 2. So 2 pi over 12. So I did that so that I can go in easily now and add my quarter period every time. Starting from negative pi over 12, if I add 2 pi over 12, where do I land? Positive pi over 12. So the calculation that I just did in my head, or that we just did in my head, we just did in our head, is this. We said, okay, negative pi over 12 plus 2 pi over 12, add the numerators, negative 1 plus 2, positive 1 pi over 12. So this is coming from. And then you do it again. If you add another 2 pi over 12, you should get 3 pi over 12. If you add another, you'll get 5 pi over 12. If you add another, 7 pi over 12. And if you can't do that in your head, then you have to come over here and say, all right, after my first quarter period, I then have to add another quarter period. 1 pi plus 2 pi is 3 pi over 12. So there's my next important x value. Then I add another quarter period. 3 pi plus 2 pi is 5 pi over 12. There's my next important x value. Then I have to add one more quarter period, which leaves me at 7 pi over 12, which is my final important x. So hopefully most of the time, if you get a common denominator here, you'll just be able to do it in your head. But if you can't do it in your head, then you actually have to write it out. I don't really care, as long as you get these numbers right. So you see where all those came from? Okay, what about my y values? What do we bounce in between here? 2 and negative 2. 1, 2, 1, 2. Now you have to be a little careful here because, let me show you. All right, so let's start graphing this. Cosine, usually cosine starts from a max, but we've reflected it. So when I start graphing this, I'm going to go down to a minimum. So my starting x value, which is negative pi over 12, I'm going to go down to a minimum. I don't know why, okay? But all of the training or all of the habits you have in your head are going to tell you to go to the origin next. You don't. Right? Why do we skip over the origin?
It's not important.
It's not one of the important x values. It doesn't land on a quarter period. The next quarter period is pi over 12. So you'll do a lot of problems where you hit the origin, and that'll make you think you always have to hit the origin, but you don't. Okay? The next important x value is pi over 12, so my 0 is at pi over 12. Then I go up to 3 pi over 12, and I get a max. Then I go to 5 pi over 12, and I get a 0. Then I go to 7 pi over 12. So this is my cosine.
So that's the whole period.
That's
And
one
then
period.
exactly 2 pi over 3, if we figured that out.
Right, so the question is, can we check? Do we know that we actually went 2 pi over 3? So if you look, the period starts over here at negative pi over 12, ends at 7 pi over 12. So how do you know, how can you calculate how far you've traveled here? Subtract them. You can do final minus initial. Right, if you take this value and subtract this value, that'll give you how far you've gone. 7 pi over 12 minus negative pi over 12 is equal to 8 pi over 12, which reduces to 2 pi over 3. So that's a good check that you got it right, absolutely. Yes?
Why did you start at negative 2 again? On the y-axis?
Because normally cosine starts from a maximum. Normally cosine would start up here, but it's got a negative in front, so you have to reflect it down. So actually for cosine, you're always going to start at whatever your a value is. Since there's a negative 2 for my a, I know cosine's going to start at negative 2.
Oh, so whatever's in front of a is better.
Yeah, whatever's in front of the cosine. Now for sine, that's not true. Right? For sine, you always start at 0. And then the a tells you whether to go up or down to positive 2 or negative 2. Questions? So, one last question. What if I asked you to graph instead of this equation? I gave you y equals negative 2 cos 3x plus pi over 4, but then I put a plus 5 on the outside. What is that's a vertical shift. So when you add or subtract a number outside of the parentheses, outside of the function, that's going to move you up and down on the y-axis. So the strategy for graphing this is basically graph this guy first, right, which we just did. And then because of this, move everything up 5. All the points go up 5. So if I wanted to graph, let me do it underneath here. This function with the plus 5 out on the end, all my x values will remain the same. All this changes is y values. So all my important x values will be exactly the same. Negative pi over 12, pi over 12, 3 pi over 12, 5 pi over 12, 7 pi over 12. So the plus 5 on the outside does nothing to these. But all my y values have to come up. So instead of going to a minimum of negative 2, what's my minimum going to be? 3. You have to add 5 to it. And instead of going to a maximum of 2, you're going to go to 7. Another way to think about that is you can just think of, this is how I usually think about it, you can just move the x, you can picture moving the x-axis up. Right? Instead of this x-axis being at 0, it's going to be up at 5. And so you kind of imagine, I have to scale it down a little bit in case you couldn't tell. Kind of imagine this y equals 5 line as the line that you oscillate around. And then you go down 2 and up 2 from this guy. Right? So down to 3, like we said, then up to a 0. A 0 means you hit the y equals 5 line. Then up to a maximum. Down to a 0, which means you hit the y equals 5 line. And then down to a middle, which means you hit y equals 3. So either you can just literally take all these points and move them up 5, or you can just imagine moving the x-axis up 5 and then oscillate up and down 2. That was your amplitude. Most importantly, though, when you have a plus outside, it affects y values, not x values. And be very careful, because if you see something like this versus something like this, there's a huge difference. What's the difference in these? Yeah, one of them is going to give you a phase shift, right? One of them has a c of -5, which means you're going to start at -5. One of them has a vertical shift, which means you're going to graph cosine and then go up 5. And so this guy affects y values. Plus 5. This guy affects x values. You have a phase shift. -5. So watch those parentheses and where the numbers, whether you're adding or subtracting in parentheses or out of parentheses.